Hi guys, in this video we're going to be talking about some of the properties of logarithms that tend to show up from time to time as we evaluate logs. And so I'm just going to look at this basic set of 5 properties right here and then talk about how they are useful when we recognize them occurring with logs. So the very first one is just this: log base b of 1 is equal to what? And so as we look at, say, log base b of 1, it's kind of like saying log base b of 1 equals a question mark here. If we rewrite this into exponential form, what we see is that we get this sentence in exponential form that says b to the what power equals 1. And so this is one worth memorizing here, and that is to say that anything to the 0 power is equal to 1. And if we say, why is this true, we're going to rewrite this as because b to the 0 is equal to 1. So you can see that if I had to evaluate this here, rewriting it into exponential form made it a whole lot easier. Let's take a look then and ask what would have to be true about log base b of b. What could we raise b to the power of, not to get 1, but what could we raise b to the power of to get itself? And so for something like this, again, if we were to kind of write this out, we say log base b of b equals what? Well, this would be tantamount to asking b to the what power equals itself. The only way this could be true is if it's equal to 1. And as for the because, we say, well, because b to the 1 is equal to itself here if we rewrite this into exponential form. So a couple of really important logs. Anytime we take the log of 1, we'll get 0. And anytime we take the log base b of b, or of itself, we're going to get 1 because anything to the first power equals itself. Now, in terms of these next two properties right here, we are going to name these. These are our inverse properties, okay? These two numbers, 3 and 4. And the way this works is, log base b of b to the x equals what? I'll write that over here just because I have room. Log base b of this thing right here is equal to what? I am going to encourage you to go with me on this journey. We're going to rewrite it again, but we say b to the what power is equal to b to the x. And so I hope you recognize that this is just our one-to-one property of equality. And we say that the only way this can be equal is if this question mark right here is actually equal to x. Okay? And so we're going to say that log base b of b to the x is equal to x, but because b to the x equals b to the x, if we rewrite it into exponential form there. So another way to look at this is just when you take the log base b of some exponential thing and they have the same basis here, what happens is the log and the base part of this cancel out, and what we get left with is just the exponent part of it. So it gets the name inverse property just because we look at it as the log base b is undoing the exponential thing base of b, and we just get left with the argument here. Likewise, this one looks a little bit different, but let's put parentheses around our log base b of x here. This actually says b to the power of log base b of x equals what? And so this one's a little bit different. This is already an exponential form. What I want to do is rewrite it into logarithmic form. So I'm going to go ahead and set up my little skeleton here. Log base b of something equals something. And I'm going to make sure I play it safe. It's a little bit harder to go from exponential back to logarithmic form. We're going to say, okay, now I'm all set. What's my base on this exponential expression? And the base here is b. So the base on my log is still b. And we say b to the power of what? Well, it looks like we're raising b to the power of log base b of x. And what we're getting as our output is a question mark. And so this leads us to what we're going to look at next, which is property 5, but it's our one-to-one property of logarithms. And it says that log base b of x equals log base b of y if and only if x equals y. So in this case here, because log base b of question mark has to be equal to log base b of x, that means that the question mark and the x must be the same thing. In other words, we get b to the power of log base b of x is equal to x. And this is true because log base b of x equals log base b of x, how we've written it right here. So the fact is, these two inverse properties kind of say that if you take a log base b of an exponential thing, base b, then they're going to cancel out and you're going to get your exponent here. But if you take an exponential expression, base b, and you raise it to the power of a logarithm, base b, as long as these bases are the same right here, they're going to cancel out and you get left with this argument right here. Okay. And then, of course, our last property is our one-to-one property of equality, which really is just the same thing as our one-to-one property of equality with exponential things. It's just that they have logarithms that are both base b and they're equal, and so their arguments, x and y, would have to be the same exact things. So let's take a look at using these properties and maybe kind of try to point out which ones we're using. But it says use the properties of logarithms to easily evaluate the following logarithmic expressions. Well, this one here If I said what would this be equal to, another way to write this is actually log base 4 of 4 squared. And I notice that 16 is already a power of 4. And so in this case, because I am taking a log base 4 of an exponential thing base 4, what tends to happen is those things cancel and I just get 2. So one thing I want to throw out there is if you were trying to answer this and you rewrote it into exponential form, like this, you would still arrive at the same conclusion, okay? It's just that we wanted to use the properties to do this, and it looks like we could use our inverse property number 3 here to do this, okay? So when we look at letter B here, we say log base 5 of 1. Well, which one of these properties up here dealt with taking the log of 1? Well, it was this first one right here, and it says that it always equals 0. Now, with respect to why is this true? Because 5 to the what power equals 1 is what we were asking in the first place, and the only way that makes reasonable sense is if our exponent is 0. And then we get letter C here. I suppose you look at log base 4 of 2. This one's kind of an interesting one here, but I suppose that what I want you to consider is that 2, this one's kind of a tricky one, log base 4 of 4 to the 1/2. 2 is the same thing as the square root of 4, and as we write I suppose a to the 1 over n power, this means the same thing as the nth root of a. And so in any instances where we're evaluating the log base 4 of, say, this thing here, if I can rewrite it as having the same bases, then I can use my inverse property again. But I had to think about what is 2 the same as, 4 to what power, and that'd be 4 to the 1/2, because the square root of 4 is equal to 2 there. So if that's the case, we do end up with a half here. And again, if you were to look at doing this the longer way, saying, okay, what can I raise 4 to the power of to get a half here? You'd have to think that, first of all, that it got smaller, okay? And so when we say, what can I raise 4 to the power of, oh, sorry, to get a half, to get 2. What can I raise 4 to the power of to get 2? This would have to be some sort of a root or a radical, and in this case, it would have had to have been a square root, and so we could say that that question mark or unknown is equal to a half, okay? So for the last part of this, what I want to do is just kind of look at how we could use the one-to-one property to help us solve logarithmic equations, which is going to be a big emphasis in the last section of this chapter. But one thing we want to keep in mind is anytime we have two logarithmic expressions that are equal, so a log equals a log, and their bases are the same, then we can always use to our advantage the one-to-one property, which says, hey, you know, their arguments also have to be the same. We can take a look at that here. Log base b of x equals log base b of y if and only if x equals y. So in this particular case here, we could say, well then, you know, I can set y equal to 16 and I'd be done. And it'd be real easy to check this by putting a 16 back up in here. We would say log base 5 of 16 equals log base 5 of 16. But when you have, say, log base 10 of 4 minus 3x equals log base 10 of x plus 2, or the common log of these two things, it's still one-to-one, but what we have to do is we have to set their arguments or their inner parts equal to one another. So to solve this from here, we would just go ahead and use best practices with algebraic solving techniques here. We say 4 equals 4x plus 2. In this case, we could subtract our 2 from both sides, and so we get 2 on the left equals 4x. And this would leave us with the fact that x equals 2/4, or in other words, we would get a half, okay? So for this last one here, I want you to take a look at, we've got some quadratic thing here. Log base 3 of x squared plus 4 is equal to log base 3 of 29, if and only if x squared plus 4 is equal to 29. So one thing to keep in mind here is, just going into this, is as I solve it, it's a second-degree polynomial equation, so I should expect to get two answers. We can actually solve this one using square roots, and so we get x squared equals 25. So in this particular case, if we take the square root of both sides, we're going to get x equals plus or minus 5. Okay. So one thing I want you to keep in mind is that whenever you get a negative answer, especially, but anytime you get an answer with logarithms, you should always go back and plug it in to check your answer here. But if I were to plug in positive 5, I suppose I would get log base 3 of 5 squared plus 4 equals log base 3 of 29. And what I want you to notice is that when we square that 5 there, it gives us a positive 25, and so we get this log base 3 of 25 plus 4 is equal to log base 3 of 29. And so this is very much a true statement. My question is, if we had put the negative 5 in here, would it still have worked? In this particular case, it would have worked just because negative 5 squared still gives us a positive 25. And so we're going to keep both of these solutions here. So properties of logarithms. We want to know that the log of 1 is 0 and the log base b of b is always 1, but especially these two inverse properties, we want to pay attention to those there. And then our one-to-one property is going to assist us in solving logarithmic equations. Cheers.